Hi, juniors. Your shop teacher Chief here, continuing our series on sheet metal fabrication and layout. Late at night, shop is quiet. I want to pause and give you some instructions and concepts of radial line development. What I'd like to say is if you look at this project that we're about to embark on next week, it's a cyclone dust collector. Like I said before in the other series, every carpentry shop, industrial paint shop, industrial buildings that you see in cities and factories will have a dust collecting system, and a sheet metal worker will fabricate that, lay that out, weld it, and install it. So that's what we're about to do next week as a team project. I'd like to sort of talk, what I have here is basic drafting and sheet metal layout tools, which are essential to a sheet metal worker. Step by step, we'll go over this process. It may look complicated to you, so is a little bit of shop math, a little bit of 3.14 pi r radius. There's a little bit of sequential steps that we need to take, but we can get there together. So I wanted to give you an overview of what we're going to make next week as a team. Once again, we work with tape measures a lot in our trade, but for now, we're going to pause with the tape measure, set it aside, and we're going to do some accurate layout with a little bit of shop math. I'll use a Sharpie so you can see the lines. So I'm just going to set aside. What I have here is a compass. A compass is in mathematics and paper is for drawing circles and radiuses and stepping things out. In our trade, we call these wing dividers for sheet metal layout and regular layout for heavy steel as fabricators and pipe fitters and iron workers. But for a sheet metal worker, I modified this wing divider. I put a pencil on it so we can conceptualize the concept of a radial line development cone on a piece of paper. So the first thing I'm going to do is I'm going to start out with my base. My base is going to be 9 inches. So the cone will be 9 inches wide on the base. Half a 9 we know is 4.5. I'm going to use a Sharpie so you can actually see that on the video. I know we don't lay out in Sharpie, but for right now, it's essential that we do. I'm going to come in with a right angle. I'm going to come up. The cone is 9 inches tall. So I'm going to come up 9 inches. Once again, there's my 9 inches. I'll take my Sharpie so you folks can see that. I usually don't lay out in a Sharpie. I know we can come over. On the top of the cone will be 1 inch. So a top 1 inch on the left, 1 inch on the right, a total of a 2 inch frustum of a cone. A frustum of a cone is a cone with the top removed. Once again, my base is 9 inches. My height is 9 inches. My top of my cone is 2 inches. I'm going to take my straight edge on my base at 9 inches on each end. I'm going to come in here. I'm going to connect my dots, and I'm going to draw that all the way up until it intersects out there. We don't know where it will intersect, but that's going to be our pivot point, if you will, which we have right there, folks. That right there is your critical pivot point for developing radial line development. So next, I'll take my wing dividers, my compass. I'm going to set it at that point. I'm going to drive my wing dividers, open them up, secure it, and send it out. into your radius. Don't need to do a full circle. We won't get that far. So with that said, adjust your wing dividers again, once more, for your 2-inch, for your top of your frustum of your cone. Send that out. Don't need to make a full circle. At this point, so you can see the line, I'm just going to give you some dotted lines with the Sharpie. I usually don't do this, but for instructional value, I'm just going to give you some dotted lines so you can see on the video. Once again, those are my radius lines that I just developed. So at this point, we'll do a little shop math. We know that the base of the pattern, we'll come over here, was 9 inches. So we know that we're working in a radius, we're working in a circle. We know that the formula is 3.14 times the diameter. We know the diameter is 9 inches. We're going to take 9 times 3.14, and that comes out to 9 times 3.14. That comes out to 28.26. So that's 28 inches and 1/4 inches. So 28 and 1/4 is going to be our step out. So I set that aside, and once again, I go back to my small compass. I set that for a 1-inch interval. I'm going to step that out 28 and 1/4 inches for my circumference. So here we go. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 20. 1, 2, 3, 4, 5, 6, 7, 28. I'm going to come in here with a 1/4 inch on my scale. So there's 28. There's a 1/4. Now we're going to connect the dots. So I'm going to go back to my pivot point, like we did before. Come over to my 28 and 1/4. And draw my line. And then at that point, folks, what you see right here is your cone pattern. So all this will be cut away with a set of scissors. Out here will be cut away with a set of scissors. This will be cut away. We don't need this anymore. This will be our pattern. We need to have a tab. So we're going to come in. We're going to make a 1/2 inch tab. Come over here. Connect the dots that you just made for your tab. Come in on an angle. Come in on an angle. Save. TAB, your tab, which is a 1/2 inch. Okay. Out here will be cut with scissors. And this pattern is what we'll save, folks.